Alright, today we're going to look at area approximations, and I've said that antiderivatives give you area. We still haven't seen how that happens, but today we're just going to look at ways of approximating area. So why is area useful? Let's review how area helps us when we have something like this. If we have this graph of velocity, and the velocity is decreasing over 3 seconds. Well, when we multiply base times height, we're multiplying feet per second times seconds. The seconds will cancel, and we'll have feet. So in this velocity graph, the antiderivative, or the area of this graph, the area between the line and the x-axis or time axis, is going to be the distance that it traveled. So we could say that if we have a triangle, we'll go 1/2 base times height, and we know that the object that is represented here traveled 6 feet. Alright, that's one reason why we want to know area. So now let's review how to find area. So in this graph, if we just looked at that, it's a constant function. We can just go base times height, and we know that that rectangle would be the area. We find the area of the rectangle. Here we have a trapezoid, so we would have to find the mean of the two parallel sides. So that's a 1 and that's a 3. We could say that it's going to be 1 plus 3 over 2 times this distance, which I didn't give you, and that's 4. So that gives us 8. 4 over 2, we get 8. If we have a curved shape, then we need to divide it up into intervals, and we could either use trapezoids or rectangles, and that's what we're going to focus on today. When we found the areas here, we did not approximate anything. We found the exact area, but for this curved line we're going to have to approximate it, because we might draw trapezoids with straight lines, so the areas of the trapezoids would be less than the actual area, but they'll be pretty close. So in addition to trapezoids, we could also draw rectangles. Like that. And we'll look at today using trapezoids and rectangles. Approximate the area under this graph. That's a 2 between these values. So we have this graph is shifted up 1 and it's curving down. We have, oh, and I forgot to tell you this, using 4 right-hand rectangles. No, let's not say 4 rectangles. Let's say 4 intervals. Okay, we're starting at -1. We're going to 1. That's what it's telling us there. We're going to divide it up into 4 intervals, 1, 2, 3, 4, and when it says right-hand rectangles, that means the height of the rectangle is determined by the right endpoint. So here we have an interval. We use the right endpoint and go up to the curve. That's going to be the height of the rectangle. Here's another interval. Here's the right endpoint. We go up to the curve to draw the rectangle. The right endpoint, go up to the curve, draw the rectangle. The right endpoint, the curve is touching the x-axis, so there's no rectangle here. The height is 0. And all we have to do is find the areas of these 3 rectangles, and that will be our approximation, our right-hand rectangular approximation. So we can say that the area is approximately the area of this, which is, here we have -1/2, and we're going to go base times height. The base of this rectangle is 1/2. The height is the y value at -1/2. So we're going to use 1/2. Let's do the y value, -1/2 squared plus 1. So here, this is the y value of the curve at -1/2. Then we'll have the base of the second rectangle and the height of the second rectangle. The height of the second rectangle is going to be at x equals 0. We put a 0 in there, and we have 0 squared plus 1. And then we're going to go the base of this rectangle times the height. Base is 1/2. The height is 1/2 squared plus 1. -1/2 squared plus 1. Alright, that's going to be -1/4. So we get 3/4. 1, -1/4, we get 3/4. So we have 3/8 plus 4/8 plus 3/8, 6/8, 10/8, or 5/4. Alright, and in the previous problem I said intervals, and we should also actually say sub-intervals, because this is the interval, and then we're breaking it up into smaller intervals. Alright, pause the video and try that one. We're going out to 2, parabola, so that means we're going up to 4 if we square it. And over 1, up 1, over 2, no, 1 is right here. So I made it with, this has 4 subintervals, ignore that, and when we substituted 2. If we square 2, we get 4. If we square 1, we get 1. And there's the graph. Alright, 4 subintervals, so that means that's a half, and that's 1.5. And we're going to make right-hand rectangles. So with this interval, the height of the rectangle is determined by the right endpoint, and then we draw a rectangle. The right endpoint, the height, is determined by the right endpoint. And now we find the area of all the rectangles, and that's going to be the base is a half. The height is 1/2 squared. The next rectangle, the base is a half, the height is 1 squared. Then we go 3/2 and 2 squared. So that's going to be 1/4, that's 1/8. 1 times a half, 9/4, 9/8. And 4 over 2, we're going to leave it as 4 over 2. So now this will be 4 over 8, and this will be 16 over 8. So when we add all that up, we get 30 over 8. Or 15 over 4, and that's our approximation of the area under the curve. Alright, so this from the first example, we have a parabola, and we need 4 subintervals, so we're going to divide it up like that from -1 to 1. But now they're left-hand rectangles, so that means the height of each rectangle is determined by the left endpoint. Here's an interval. The height of the left endpoint is 0, so we don't have a rectangle there. Here's another interval, subinterval. We use the left endpoint, and that's the height of the rectangle. Here's an interval. Use the left endpoint and use the height of that, of the function. Here's a subinterval. Use the left endpoint and use the height of that at that x value. We just have to find those areas, the area of those rectangles. So we're going to have the base. Here we have 0 height, so there's nothing there. Base is a half, and the height is the y value at -1/2. So here we have the y value at -1/2. And then we're going to go to the next rectangle, and the height is at 0. The next rectangle, base of 1/2, the height is at 1/2. So this is going to be -1/4, that'll be 3/4, 1/2 times 3/4. we end up with the same thing that we had before, 5 over 4. Alright, approximate the area under the curve on the interval 0 to 2 using left-hand rectangles with 4 subintervals. That's not a G. Find the area under the curve on this interval using left-hand rectangles with 4 subintervals. So pause the video and try that one. Zero to 2. And with a left-hand rectangle, we'll use the left endpoint. So if I'm looking at this interval, the left endpoint has a height of 0. Here's another interval. The left endpoint has a height of 1/4. So we have 0 area here. Here we're going to have base is 1/2, and the height is 1/2 squared. For this rectangle, I didn't draw it. There's the rectangle. For the interval from 1 to 3/2, we have a left endpoint, and there's the height of the rectangle. So we have base of 1/2, and the height is 1 squared. Here we have another interval. The height is determined by the left endpoint, so we go to the function, and now this is going to be 1/2 times the height at 3/2. X value is 3/2. We plug it into here to find the Y value. So 1/4 times 1/2. Here we have a half. And we have 9/4, that's 9/8. So 1/8. This will be 4/8, 14/8, or 7/4. Okay, let's approximate the area under this. And we're going to have the interval -1 to 1. Let's have 4 subintervals. And now we're going to use midpoint rectangles. Alright, here's another strategy of creating the rectangles. Four subintervals. But now to find the height, we have to use the midpoint of each subinterval. When we used when we use left hand or right hand rectangles, sometimes we were missing a rectangle. So if we use midpoints, we'll get a rectangle in each interval for this graph. So we're going to use the midpoint, go up to the graph, make a rectangle. Use the midpoint, go up to the graph, make a rectangle. So the area is approximately the base, which is still 1/2, but now the height is going to be, this is -3/2, so we're going to put -3/2 in there. Then we're going to go base is 1/2, and this is oops, that's not 3/2, that's -3/4, and that is -1/4, -1/4 there. All right, the base here is 1/2, and the height is at 1/4, so we have a -1/4 squared plus 1 plus, let's do the last one, is 1/2, and this is at 3/4, so we're going to go 3/4 squared plus 1. Nine over 16 plus 16 over 16, that will be 20, well that's -9 over 16, I'll just write it down. -9 over 16 plus 16 over 16, this will be -1 over 16 plus 16 over 16, and another one, and then that'll be the -9 over 16. So we add all that up, we end up with 44 over 32, 11 over 8. Okay, let's go on to trapezoids. Alright, so we have the same graph. Parabola, we are going to have four sub-intervals, but now we don't draw rectangles, we're going to draw trapezoids, and we should get a better approximation with trapezoids. So the area, here we just have a triangle. We can just use the formula for a triangle. 1/2 base times height. 1/2 base times the height, and that's the height at 1/2, so we put a 1/2 in there. Okay, the next trapezoid is going to be the mean of the heights. So we have negative 1/2 squared plus 1. This is the height at 1/2, and then we're going to have the height at 0. So the trapezoid has two heights. That's height on the left, height on the right, divided by 2 to find the mean, and then we'll multiply it by the base. We're going to do that again for this, and then this will be over here. So we have plus, do that again. It's going to be negative 0 squared plus 1 over 2, not over 2 yet, plus alright, so we're looking at this trapezoid. We need to have this height at 0, so I put a 0 into the equation, and we need to have the height at 1/2, so I put a 1/2 into the equation. These are the two heights. We want the mean of them, so we add them and divide by 2, and then multiply by the width. Then we have on the end is a triangle 1/2 base times the height. The height is the height at 1/2. And that is going to be, the height at 1/2 is 3/4. So I'll just put it in there because I ran out of room. So this is negative 1/4. That'll be a 3/4 times 1/4, 3/16. This is 3/4 plus 1, so 7/8. No, it should be 7/16. This will be the same, and then this will be the same as that. Alright, one more. Alright. Pause the video and try that one. We're going to use 4 subintervals and trapezoids on that interval to approximate the area under the graph. Four subintervals, trapezoids, and why don't we just write out the y values here, or we do a table just so we don't have to write so much in the expression. So at 0, the height is 0. At 1/2, the height is 1/4. At 1, the height is 1. At 3/2, the height is 9/4. And at 2, the height is 4. And then we can just use those y values. So the area of the first trapezoid, we could write it as a triangle. You could also do it with the same trapezoid formula, because the left side is 0. The right side is 1/4. Divide by 2, multiplied by the base. For this trapezoid, the left side is 1/4. The right side is 1. Divide by 2, multiplied by the base. For this trapezoid, we're going to go 1 and 9/4, 1 plus 9/4 over 2 multiplied by the base. And this last trapezoid is 9/4 and 4 divided by 2 multiplied by the base. And we end up with 11/4. All right. And we'll stop there.